This video is a follow-up of sorts to one of the entries in my top 10 list for 2022, in which I mentioned the work of one Hyu-Hoon Chai, an astronomer at Sejong University in Korea, who appears to have made it his life's work to dispel dark matter in favor of MOND, or modified Newtonian dynamics. If you need a refresher, dark matter does not actually exist. What we call dark matter is really just a misalignment between what our theories tell us to see and what actually shows up when we look. For instance, according to our understanding of gravity, stars should revolve more slowly at the edges of galaxies than at the centers. But in fact, stellar speeds across galactic disks are relatively constant. Also, galaxies across the universe behave as if they had far more mass than their star count suggests they should. These facts have proven difficult to dislodge, and have remained consistent across multiple lines of evidence and nearly a century of observation. When confronted with such a discrepancy, one has two options. You can assume that they indicate the presence of an element of our universe as yet unseen, or that our theory is fundamentally wrong. The general rule is to assume the first before the second, and today the majority of physicists conclude that these observations assert that the universe is full to bursting with invisible matter, undetectable through our telescopes, yet outmassing visible matter by 5 to 1. They call this elusive substance dark matter, though one should only read that metaphorically, as unknown rather than literally. If dark matter were actually dark, it would be ridiculously easy to detect, since it would blot out light from other galaxies. Dark matter is actually transparent, which is far worse. Assuming, of course, that it is there. There is always the far more tantalizing possibility that we may be seeing evidence for a new theory of gravity. Over the last few decades, the majority of theories to dispel dark matter have fallen under the umbrella of MOND, or modified Newtonian dynamics, which posits that, at very low accelerations, below a nanometer per second, such as is found at the edges of galaxies, gravity strengthens and begins to dissipate linearly rather than exponentially, as predicted. That appears to be what Dr. Chai believes, and in 2022, he claimed to have detected, within the gravitational curves of several thousand galaxies, a kink that corresponded to the predictions of MOND. This year, after studying the motions of 27,000 wide binary stars as logged by the Gaia telescope, Chai once again claims to have found evidence more compatible with MOND than with standard gravity, to a certainty level of 5 sigma, or 99.99997%. And he wasn't the only one. A separate paper published this month by Xavier Fernandez of Mexico's Universidad Nacional Autónoma came to the same conclusion. The binaries studied were all separated by more than 1,000 astronomical units, meaning their accelerations were all below 10 to the minus 10 meters per second. Binaries such as these offer an enticing chance to test dark matter, since dark matter's effects are only measurable on galactic scales, not interplanetary distances. I have to admit, I initially held off on writing about this. The press release for this discovery was so uncritical and certain that, were it true, even given our eventful era, every newspaper in the world should have been emblazoned with the headline, "Einstein proven wrong." As this did not happen, I searched for alternative viewpoints. And thank you, Ethan Siegel, for some much-needed perspective. He pointed out that 2 months ago, Indranil Banik of the University of St. Andrews in Scotland, after studying the same dataset, came to the exact opposite conclusion, that Newtonian mechanics are sufficient to explain the motions of wide binaries down to nanometer accelerations. And he claimed a certainty of 16 sigma, which, if my mathematically illiterate attempt to calculate it holds true, is somewhere around a nonillionth of a percent, below 100. So what, as they say, gives? How can two interpretations of the exact same information come to such radically different conclusions? Well, Siegel notes, the biggest problem is that these wide binaries have orbital periods of thousands of years, and even if Gaia is the best and most precise astrometric dataset in history, which it is, it would still require centuries of observations before we obtained enough data to accurately map their entire orbits. That's not to say that the papers didn't have ways around this. They examined a sample of thousands of binaries and employed probability models to produce their results. Such models, however, are constrained by the assumptions used to make them. For instance, How many binaries are actually trinaries, or higher, their companions hidden in the swarm of stars? How many paths are affected by the gravity of invisible substellar material, such as massive Oort clouds? How many are not in fact binary at all, but merely in temporary lockstep in their trip around the Milky Way? If the answer is anything other than none, then it will affect the results. MOND is, and always has been, a deeply flawed hypothesis. For one thing, it doesn't even attempt to explain the extragalactic effects of dark matter, confining itself solely to the motions of stars. For another, as its name suggests, it modifies only Newtonian dynamics. It says nothing about general relativity. But in a sense, that doesn't matter. Sketchy and ad hoc MOND may be, but if a consistent result could be found that agreed with it, however minute, it would be the thread that unravels the way to a revolution in physics. It's not surprising that many are determined to find it, but until they do, dark matter, whether it exists or not, will be the base assumption on which our conception of the universe is built. I hope you enjoyed this video. If you did, please remember to like, comment, and subscribe. Or if you'd really like to help, check out my Patreon. Or if that's beyond your means, just tell someone else about my channel. An informed universe is a better universe.